I think, okay, that's fine. So yesterday we looked at mainly on a big introduction into Rust. We looked deep into what Rust is. We did some guessing game to just get deeper into involving ourselves into this huge language called Rust, which is awesome and interesting. And today we are going to be more deliberate. One of the things that we are going to look at the core components of Rust, which is ownership. Um, can you kindly reshare the YouTube link? Okay, let me share a bit of the youtube.com slash
Yeah, I've shared it.
record. Thank you.
Yeah.
We also have a Telegram channel. I thank you for that help. It really helps me to keep focused. So today we are going to be mainly talking about that, about ownership. We are also going to look at statement and expressions. And I think let me start sharing my screen so that we can get started. Okay, hope my screen is visible. I often forget to increase these. So let me put this here. Control Shift Plus. All right. So I think we can start from there. So we can start by. Okay, I think I'm in. Okay, let me change to the dot. I think we had put our projects on desktop. Okay, so the folder was called Polkadot builds. CD Polkadot builds. CD Polkadot builds. It's capital P, okay. Polkadot builds. So okay. So I think I'm going to make a directory called day2 and seed into this directory. So we said when we want to start our Rust project, we started with cargo, new, and then the project name. So we are going to start with a concept of expressions and statements, and we shall see how these are very crucial in the Rust programming language. So I think I'm going to just name it express. Yes. So we've created it. Excuse me. And we seed into express. Hopefully everything is okay on YouTube. I didn't check so well, but yeah, we shall just keep going. We shall also upload this on, yeah, We shall also have this uploaded, so in case the stream wasn't okay. So we're going to uh, bring up Code. So Code is opening Visual Studio Code. So you can use your editor. And we talked about the cargo.toml. We talked about the source folder. We talked about the cargo.log and the main.rs yesterday. So let me try to increase this. This is okay. We talked about the target file folder where you built exe and programs are kept. So is the text visible enough? Hopefully it is. Right. So here when we talk about statements, statements are just like the normal way we have written the print. Yeah. Maybe for example, I can say I want to look for an example that I can select x equal to, I can call, let me call a function, probably it could be 5. So yesterday we didn't get an opportunity to look at external functions. So this is one. We as we have other external functions in other programs, it's the same here. So the program starts in the main function, and then we can call other functions. So let me say fn5. This is our function. So for this statement, doesn't return anything. Probably so when I save this, um, and maybe let me run it. See, hopefully I have no issue. So this one brings, this is a statement function, and just like that. So what the main function is doing is assigning a variable x to this function 5. For expressions, we are having functions that return something, and these functions that return something always don't have the last semicolon. So let me change this into a function, into an expression. So we are calling this function. This function 5 is going to return an expression. And I'm trying to see how we can make this. So for an expression that is going to return something, you have to explicitly name what you want to return. So let's say we want to return an integer. So if you want to return an integer, we shall introduce this as a return type. So this is what stands for the expression. And now for this function, so this function says that the function 5 will return a value of a type integer. Or yeah. So now in case I can return any value, I can return something like that. I can return 10. But you realize that here you don't use a semicolon, and this is very important. You can find this in Rust and say, why didn't they use a semicolon? So if we are to run this, clear. Okay, cargo run. This is a statement function. Oh, it is not saved. So if I save, I had not saved, so it was still reading the other. Clear. Control S is used for saving. Cargo run. Yeah. So you realize that the function has built successfully. Let x equals to 5. Help if this is unintentional. Okay, you can prefix it with an underscore. That is okay. But yeah, this when we put here a semicolon, you quickly realize that we have an error here. Yeah, with the closing tag. So this is something that wanted to highlight for expressions. We can even take it further a bit, and maybe we have let y to be bound to or be assigned to be we bring a new function. So this is how we call functions. Plus one. And then this we want to always add something. So plus one. So maybe if I give it a 10, you want to return, want y to have something, yeah, to have one added onto this. So I can have a function is plus one. Now, due to this value here, I have to explicitly name a variable here. It could be my label or my number, my num. So you can read these, the integer types or strings and so. Yeah. So this is for this. And then the return type is going to be what you want to return. You also want to return an integer of type i32. And this is the power, one of the power of expressions. So probably we can have, want to have, so let, I think even if we don't name, we just say enum equals to bring the above value, I don't know, one. So in case we put a semicolon, that's an error, cannot run. My program cannot run. It already shows the error. Expected just I32 found something, error 308. So yeah, whenever, most of the time when you're returning, I think always when you're returning, you leave that. And maybe if you want to see our returned value, our returned variables, we can print ln yeah, x value, I think x value yeah, x, so that x is usable. Then we can also print the y value using the print macro. Value by save and cargo run. So yesterday we looked at cargo run, cargo build, cargo check, and yeah, we can see our return values. X value is 10 and Y value is 11. So that's the power of expression. Okay. And now we are going to go to one of the most important topics, I think, in Rust, which is called understanding ownership. So we can look at this thing called ownership. It is not more common in other languages, other statically typed languages, but it is very common in Rust. And if you get it very well, Rust becomes a ton of miles easier for you. So let me check in the chat. Might be running very speedy. Okay, hopefully everything seems to be good. Um, so we can look at ownership. Okay. I can just and here new file. Txt. Ownership. Okay. So Rust's most unique feature, I think, is this, and has very many deep implications on the language. Enables It enables Rust memory safety guarantees without needing a garbage collector. Yeah, when we look at things like garbage collection, you look at languages like C, which do their own garbage collection. In Rust, you're given the responsibility to do your garbage collection, but with a lot of guidance. Rust is known for one thing. It is known for a lot of guidance. Will show you errors and yeah. Collection will show you errors and help you out on on debugging your code. So what is this thing called ownership? I can define ownership as a set of rules that govern how a Rust program manages memory. Ownership is all about memory. So maybe some people are taking notes. Set of rules that governs how Rust program manages memory. I don't want to start something else. Manages memory. Oh, yeah. When you talk about ownership, you're talking about memory management, and I think I'm going to explain it so much. Hopefully, we get it. But even if you don't get it at this time, you can revisit and see how and where you missed it out. So memory is fully about two variables that we're talking about. One is the stack, and the second one is the heap. Is the heap, and you're going to find out that the stack is always giving a definite memory, so where you can push and maybe values. For example, when you have integer is of a definite memory. When you have things like character, when you have immutable strings, uh, these ones can easily be stored in stack. But there are other cases where you have, for example, variables that a user must input into the program, and all you can do is just to allocate storage. So this storage that you allocate is known as a heap. Yeah. I think both stack and heap are parts of a memory available to you, to your code to use at runtime, but are structured in different ways. The stack stores values in order, yeah, and to get them in, maybe I can keep doing some notes. The stack uses this last in, first out. So, and last in, first out simply means that the way you stack up plates, more especially plates that will break, uh, the one on top is the one that you remove first. So this is the concept that the stack uses. You cannot remove data that is in the middle of the memory or at the bottom, but you start with the outmost data. But for a heap, it's all about an allocation. Okay, hopefully we are together to that level because we are getting more in depth and yeah. So adding data to the stack is called pushing onto the stack. You will find out things like something dot push, and then getting data off the stack or removing data is called popping. So pushing is adding onto the stack, and popping is removing from the stack. So from the stack. Okay. And these concepts are good to put in because with heap we don't use these. So heap has other contextual, and we shall see. So we push onto the stack and we pop out of the stack. So we pop on the top and we push, keep piling up. We last in, first out. Excuse me. So the data that is pushed into a stack is mostly of a known size, and when you want to pop data out of the stack, you again pop out of the known size. Now, when you have that of unknown size, this is where the heap comes in. So that of unknown size at compile time, or data that might change when it's stored, once stored, is stored always onto the heap. So when you put data onto a heap, you request a certain amount of space. And I think this is now one of the things that you need to get very well. That once you're putting data, because the main difference is in this explanation. So when you put data onto a heap, you request a certain amount of space. The memory allocator finds an empty space big enough to accommodate what you're requesting the storage for. So, and this memory allocator finds an empty space big enough on the heap, marks it as being in use because it is now allocating it to you, and then returns a pointer, which is the address of the location. Okay, maybe I can let me demonstrate something here. It's called Google Jamboard. The Jamboard. Um, yes, I think it's Google Jamboard. So let me start. It seems to be slow, but we shall go with it. So the way the heap works is that once you require for this data storage, somebody is making some noise. There is a background. Okay, set background. I think I can use this. So is this hopefully this is visible. So let's say when you request data that excuse me. So let's say this is our heap. And you have this information you want to store on the heap. So this is so the allocator has looked for the space, and this space is enough for you to store whatever you want to store. What it does is that the allocator returns to you um, so here we have a stack of so we have a stack of given sizes. So what the allocator does is that it finds this heap where you're going to store your data, and then returns a pointer. So a pointer is stored in this stack. The pointer to point to this heap. So let me say this is a stack uh, position. So this the pointer is stored onto your stack, and this pointer will point to the storage where your data will be stored. So to name this is a stack. So this is the entire concept. If you get that very well, that when you request for storage, you're not given a heap, but you're given a pointer to a heap, and this pointer is stored also in a stack because this pointer is of a known size. Okay, I hope we can first continue from there. So the memory allocator finds an empty space big enough on the heap, marks it as being in use, and returns a pointer, which is the address of that location. So the process is called allocating on the heap. Yeah. So when we are defining when it comes to a stack, it is pushing and popping, but when it is comes on a heap, it is allocating. So this is the main confusion. So you see that a stack does a lot of work because it stores that of given size. So it ends up storing pointers to the addresses where your heap data is stored. And most of the time when you're accessing, you access the pointer that will show you where the data is stored. Okay. Since the pointer to the heap is of known fixed size, you can store the pointer onto the stack. But when you need the actual data, you must follow the pointer. Yes. So that means that pushing onto a stack is faster because you don't need to search, you don't need to allocate, to do double allocation, because now you have a pointer, you have the actual heap, uh, and store and allocating onto a heap takes certain time. So it just takes some time. Okay, I think we can continue. It's going to be okay. So this leads us to sort of what is termed as ownership rules in Rust. Explanation. Let me see if we have questions. Because if you have gotten that explanation, things are going to be easy. Okay, I think we can keep continuing. We shall see those later. So there are basically 3 ownership rules. Each value in Rust has an owner. So value has an owner. The second one is that there can only be one owner at a time. One at a time. And then the third rule is that when the owner goes out of scope, the value will be dropped. Owner goes out of scope, the value is dropped. So goes out of scope, value dropped. So those are the main three rules that govern. For me to bring this, I use Control W. You can also click here. I use Control W. Yeah. So let's take some examples. Could we can start something new, or we can use this. Or let me just start something new. So CD cargo new. We can name it ownership. CD ownership. So, and I then call code dot. So I think I can close this VS Studio. Yeah. Alt F4. Make sure I've saved everything. Save, and then have this. Okay. Okay, let's see these concepts by code. I can start with let's say let s equal to hello. So since this is a specific data, we know that this is a string. This is stored onto a stack. It is pushed onto the stack. And print this, it will print run. So yeah. So the string in ownership. Okay. So we'll run everything successfully. Hello is here. But then now, given a scenario where we want maybe to make changes to this string, we want to push something to this string, because this is of a static memory size, it is impossible to do that. Maybe if I say s dot push str, something to mean central code. As soon as I save, I'll get an error. The no mechanism pushes a phone reference. Reference str. So this str in the current scope. Yeah. So if I want to add on to this string, then I have to change this into a heap, into a string that can access pointer storage. And here we introduce something that I can call the string tray. So string type. This is a type which stores on a heap. So the way I can name this is let s equal to string colon. So this from gives power to this string to store this variable. So this string stores data on a heap. This data type called string. Yeah, type unknown, cost to unknown. So once I save, this is string I, something with rest. Cannot mutate immutable variable. Okay, so this is now this is about mutation. I think you can make this mute, but I didn't bother for now. And then the error is gone. So that means that this can add data so onto the heap. Yeah, since I didn't want to have mute at this moment, I think uh, I can first deal away with this. So we have started introducing the heap. Okay. Let's see, let me try it here. So push is empty off. Okay. Let's see if I just push, it can also print. So this is not a character. I think we can first go with str. And yeah, the error is gone. If we are to do colon because of mutation, I think we are just going back. Let me yes. Okay. Run this so clear. Go run. Load the central code. Yeah, so this is it has run successfully, and that's we are starting to see the power of heaps, of having a heap. We can take this further to taking them in another function and then doing things in that function and returning something. Okay. So if we try to mutate, you could say that why don't we just mutate a character? Let me say, let us be bound to hello. Immediately we put a mute here, save. So we get an error. Remove this mute. So uh, the strings the s this s of this type str play everything is now getting more clear. I want to continue a bit. So when we are going to store on a heap, our memory must be requested from the memory allocator at runtime. We need a way to return this memory to the allocator when we are done. We are now trying to go deeper. So yes, we have gotten this memory, we have used it, and now we are done. So what's the mechanism of returning this memory? And this is what leads us to what we call garbage collection. So we need to carry out garbage collection, but Rust helps us in a bit. Yeah, as it shows us some errors and here and there. But also this is, let me create a file here. This is txt. So, but this is also some big problem that we really have, and we must get on how we can return uh, this memory well. So because if we return it too early, then we have invalid variables, and we if we return it twice, for example, you've used the memory, and then maybe you assigned it to another variable, to more than one variable. Yeah, it also causes a bug. So this is what forms the basis of garbage collection concepts. So let me start with an example. Let x to be assigned to 5. We'll select y be assigned to can I start with to test.txt. Okay, let me go here and come up with an example. If we have so let s1 probably equal to string from here, and then we have another s2 be assigned to s1. So this, in case we have these two variables and these are sharing the same heap, when both of them release this heap, uh, an error might occur called double freeing, or yeah, mainly double freeing. So how do we prevent this? Um, Let me elaborate this, probably because if you get this, it can also help you. But we mainly free this by making sure once we assign S2 to S1, S1 becomes invalid. So here, if I say print ln value of S1 is, so to avoid issues like double freeing, this will return an invalid figure. As soon as I save, I have an error here, borrow of moved value, so S1. So you see, once we assign S2 to S1, this value, this string is moved, and S1 becomes invalid. And the reason this is moved is to avoid things like double freeing of storage, because if S1 made a copy from, if S2 made a copy from S1, and both of them maybe freed the storage at the same time, that will be a big error, and Rust handles this very well. But if I name this S2, so the error is gone. So let me elaborate this quick and enough so that we are going. So we started with this let me say this is S1. One. Control copy, Control V. Then S2. So let's say we have assigned S2 to S1. So what mainly happens is that once S1, S2 is assigned, I want to copy this, copy, Control V, just say this S2. So once S2 is assigned to S1, this S1 is invalidated. This is invalidated. So and it no longer, let me put this, and no longer, so we now have S2 that is pointing to the heap, the pointer here. And what happens for these pointers, they always have three sort of compartments. One is the pointer, the other one is the length of this heap, or and then the capacity, which is the total storage. So in this heap, we can have things like, let me say, hello. So this now will point to this, and this will be lost. So this will prevent that problem from occurring. Okay, we can continue fast enough. We can have scenarios when we just want to have a copy, when we don't want to invalidate S2, and maybe this time we want to have a copy so that we have two copies of the storage. For that, we use a keyword called copy. It's a function. It's a function. It's not copy. I think it's called clone. A clone function. So clone will copy the. Let me say M1. Let M1 be assigned to string from sent. So for this, we can have let M2 be assigned to M1. And then this is valid. This you can print M2, because now this is just clones the other value, and that's it. In ownership, it's already 20. Mr. Jova, should we continue and complete this topic, or it's time up?
It depends, because I don't want to go beyond, I think, 20, 30.
Okay.
I think you could go stay within that.
All right.
Yeah.
Yes, I'm almost completing it, and thank you for that. So yeah, we've looked at cloning, and when you get all these concepts and how to trick around with them, then it becomes a very interesting language to really take on. But ownership can also be ownership with functions. So I think we can continue on this. Okay, this will be uploaded. Let me start. So cargo run. owner func. It's cargo new. Cargo new. Owner func. And cd owner func. So we are going to look at ownership within the functions. So how functions implement ownership. We've looked at things like cloning in case you want to make copies. We've looked at the concepts behind ownership and Alt F4. Save. Let me close that. So we can have an example here. And I can select it's equal to. So this ownership, the reason why we are using this string is because it's a heap, so it has that capability of changing storage. And say,
I think we have lost your screen.
okay, thank you for that.
Yeah.
So is it visible now?
Yeah, it's back.
Okay, thank you. Okay, so we want to see ownership by functions. So if we call, let's say, another function, it takes ownership. So most of the time when we are doing ownership by this mechanism, it's almost like the same way we do with the other data types that are stored onto our stack. So if I call text ownership, maybe, and I give it a variable s, so this is just going to call the text ownership function by also taking s. So let me say declaring function, we use fn. Ownership, since we assign, so we can have string is of type string, as we've seen up there, and I will return something. And return a print. Not return, but we can do something, like we do some, not returning, but okay. Say string on, yeah, it's like enjoying on. or anything. So if I so enjoying on, yeah. So we can take this further and probably we could pass an integer, maybe x equal to 8, and maybe we'll call a function me, I don't know, anything, and pass it. This will again have copy me, and yeah. So it's the same for int, for other things. So for int, we must have num of type the I32 because of the what we are passing, and then we just do something with whatever we've been given. Could be a print, could be doing other things. Just num. Yeah. So if you want to take it a bit further, you can return. We remember that for returning, we had this sign. So you incorporate that. Or maybe I'm going to just build on that. Picture st, let t1 be call. You can call a method. It gives owner. We want to just see how we can return. And gives owner. And explicitly say we are returning. It could be a string, could be anything, but we can return the string. We said whenever you're returning, you have that arrow and greater than sign, and then the type that you want to return. So whenever you're returning something, you make sure that you don't end with a semicolon. This is string returned. Be assigned to returning string. We know from and be returned. And then here we have just string return. Return. So on string return, we don't add any semicolon, as we said before, and that's an example. Yes, we can have many. We can have returning where we pass. Probably if I pass or is gives owner this is a function t1 equals gives owner. I can put in here something, maybe my name. So this is the way we really work with this function. So if I put there my name, so here I will have to have maybe a string called declared, and say declared string. So once I pass something, I again do it here. And yeah, I think I can stop on that. Expect a string, phone str. So
Yes, sorry to interrupt.
yes.
I think you have to convert that to string.
Oh,
Yeah, so you can add the to string, then it converts to a string. No, the argument.
okay,
The my name argument.
let me just look at that. Put a string here.
Yeah. After the curly, after the what? The quote.
Dot.
No. The my name, the dot to string.
After the quotation.
Yeah.
Dot string. Works. So thank you for that. Yeah, so we can have many things, but I think that is it. I don't know if this unused variable. Okay. Let me also try this. This is a good thing. This is what I like from Rust. It can't be like that. Yeah, you're right. My name dot to string. Hopefully this was it. I've messed it up. Anyway. Yeah, the concept has been gotten. I can stop that there. What was it? Let's equals to
first remove that string. Yeah, that one. Nice.
Thank you. So yeah, these are the ways you really go around with functions. I want to close up on on ownership with reference and borrowing. And once I finish this, I think I'll have closed the entire topic of ownership. And at least this is one of the unique topics that you'll find in Rust that you may not find anywhere. So we've been talking about cloning. We've been talking about the 3 roles of ownership, where each value in Rust has an owner. There can only be one owner at a time, and also the thing of dropping a value. But let me say you just want to use a value and just leave it. You don't want to have your value dropped because you finished using the value and what you've used for is like out of scope. Maybe you've added X onto something and you've gone with your result, but you don't want X to be dropped. So this is going to be our last topic in ownership, and I think it will be our last. Yes. Cargo new reference borrow. Reference borrow. CDR.
Sorry to interrupt.
Yes.
You are going to start a reference. You have
Next
9
time.
minutes.
I have 5 minutes.
You have 9 minutes.
Yeah, that will be enough for me. I think I can just go through it.
Okay.
And we conclude. I thank you for the timing. I love that because you can be on a roller coaster. We can also take on questions, but referencing is mainly about introducing the ampersand sign. So ampersand is like you want to borrow a variable and use it for whatever you want to use it, and then after using it, that variable does not go out of stock, out of scope. So this is the reference sign. Okay. He can give an example and conclude this with an example. And just say hello. And I can call change this. Maybe want change function where I want to change S1. If I write this, I'm calling a new function. So fn change, and since we gave it S1, this one is of type string, so my changed. My changed must be of type string. Okay, that is it. And then the push. You want to push a string to this. This Centra. I have stop 10 minutes. Okay. Centra code. As soon as we do this, cannot mutate immutable variable. That's something we started with. So to make sure that can say mute. First, even before we change this, to make sure that this is a borrowed reference whereby we are only borrowing this value and then use it, and we are not replacing as the rule stated, we can introduce this ampersand sign. So I also introduce it here. And also here. So this is the concept of borrowing. Let me see. Add mute to each binding. So yeah, I've said add mute to each binding. I shall have mute here because want to borrow and use, and then don't own, because ownership has its own issues. I think mute is supposed to be here, if I'm not mistaken. Okay, let me see what the error is saying. Not find by mute. Okay. Right. So um, mismatch types expected struct string. Okay, let us. So I think also this cannot be this. So how many minutes? I have 4 minutes. I think this is it. Let me debug this and finish it, and then. So we introduced this mutability to make sure that we can change and add this decentral code. I think this is supposed to be uh, it. Okay, so the error is gone. And then what we are doing is just borrowing this variable, and this we have said let this variable be able to be changed, but we are making sure that we are just borrowing it with the ampersand, and then we keep the mutability, and that's the main concept behind borrowing. There are very many other concepts around it, but that's mainly ownership. Maybe the challenge for the board could be to look into types, traits, and lifetimes, where you will have things like uh, point, T, T, E. Yeah, so we are going to be looking at this in, I think, the next session, handling errors and how to leverage on that. And I think, yeah, that's all for today. If there are any questions in this session, if anyone wants to say something, you are highly welcome.